So part 2, we'll continue our talk about polynomial functions. So in this chapter, chapter 5, we'll discover how to graph polynomial functions, also solve equations involving polynomials. So we already know how to graph some of them and solve some of them, but now we're going to deal with the ones that have a higher degree, so x cubes and x to the fourths. Let's start by looking at the information needed to graph a polynomial function. We already know how to find the x-intercepts of the linear and quadratic function. And how does this apply to the polynomial functions? Well, it just so happens that when you have the x-intercepts, you have something called a zero. So zeros, the definition is a zero of a function. F is a number r. So we're going to consider r to be a zero of the polynomial function. And if that is true, then the following statements are equivalent, and this is what they mean. Now, what does it mean to be a zero in the first place? Well, it does mean that if you plug r into the function, you're going to get zero out of it, hence the term zero. So if you put in this r, the result is a zero. Wait a minute, what is that really saying? Well, isn't that really saying that r comma 0 is a point on that graph? And if that's a point on the graph, that's an x-intercept, and we know what x-intercepts are. So okay, the following statements are equivalent. So r is a real zero of the polynomial function. R is a solution of the equation when you set the function equal to 0. So in other words, if I set f of x equal to 0, the result when I solve it, I get r. It's an x-intercept, which we said, and x minus r is a factor of that function. So if f of r gives me 0, then x minus r is a factor. You know, hopefully all of that makes some sense to you. So let's backtrack. So let's say that our polynomial function is a nice simple linear function like x plus 2. Pretty straightforward. We know that's a line. If I asked you to find its x-intercept, you would set the function equal to 0 and solve it and get a -2. So we know that the x-intercept is at 0. Sorry, let's not do that. At -2 comma 0. Okay, so let's backtrack and see what all this does. So x minus 2 is a factor, sure is. So 2 itself is a negative number. X minus a minus 2 gives me x plus 2. We found it by solving that equation, by setting it equal to 0. We know that the -2 is a point on that graph. In fact, it is the x-intercept of that graph. And if we plug 2 back into the function, we will get a 0. So if you try and find f of -2, you get -2 plus 2, which sure enough is 0. So it's definitely true for our linear functions. If we went through the same process with the quadratic, we would see that that's also true. The only thing we're going to add into this whole discussion is this idea of multiplicity. So multiplicity, so if you have a factor of your polynomial, it is x minus r to the m power. It's a factor of the polynomial, and m is the highest power of this factor. Then this 0 of r, 0 add r, has a multiplicity of m. And you're thinking, okay, what does that mean? Well, hang on, let's work on an example. That multiplicity is actually a very powerful tool when we talk about graphing here in a few seconds. So our next example basically pulls these ideas together. Again, it's vocabulary, making sure you understand the vocabulary of polynomial functions. Example 3 gives me a polynomial function, but it's already in factored form. So f of x is equal to x squared, and we see x plus 2 quantity cubed, and we see x minus 1 to the 4th, and we also see x plus 1. So there's zeros listed, and then we have their multiplicity. Now, normally, I usually start on the left side and work forward. This time, I'm actually going to start on the right side because it makes the most sense. So I'm going to take that x plus 5 as a factor. I'm going to set it equal to 0. I'm going to solve that and get a -5. So the first 0 we're looking at is -5. This -5 has an outside exponent of 1, so its multiplicity is 1. And then we're going to finish it. So if you set x minus 1 to 0, you'll get an x equal to 1. It has a multiplicity of 4. That's that outside exponent here. On the inside, if you set x plus 2 to 0, you'll get a negative 2. Its multiplicity is 3. That's this 3. And finally, what about that x out in front? Well, if we set x squared equal to 0, you'd square with both sides, you're going to get x equal to 0. So our last 0 is actually 0, and its multiplicity is 2. So now we've looked at the zeros and we've talked about their multiplicity. Now we're going to go the other direction. So now we're going to start off with information about the zeros and the multiplicity and write the polynomial. So if I give you this, can you give me this? So this is example 4. So example 4, we want to form a polynomial whose real zeros and degree are given. So example A says that the zeros are negative 2, 1, and 3, and it would be a degree. So f of x is equal to, I'm going to put a leading coefficient in there of a. We'll talk about that in just a minute. Okay, so what we're saying is that x is equal to a negative 2. That's what this 0 is. Well, I need to bring that negative 2 over next to the x. And when I do that, that will switch its sign to x plus 2. What about the x equal to 1? Same thing. If x is equal to 1, when I bring the 1 over next to the x, I'll get x minus 1. And with the 3, same thing when you bring it over. When I look at this, if I multiply this x times this x times this x, I will end up with an x cubed, which is why it's a degree 3. Now, we're going to assume the most simple case possible. So we are going to assume that a is equal to 1. Now, I will not ask you to expand this out, but the online homework may have you expand this out. So be careful. Do them in pairs, multiply 2 things together, and then multiply that third thing by that. So be careful. Part B, this time the information is a little bit different. This time it says zeros. It says negative 2 multiplicity of 3. And then it says 5 with a multiplicity of 1. And then it says degree 4. So when it's all done, you should end up with a 4th degree polynomial. Well, let's start rebuilding. So f of x is equal to, again, I'm going to keep throwing that a in there and then telling you that a is 1. Eventually, we're going to have pictures of graphs, in which case those a's will no longer be 1. So I want to make sure you're recognizing there is a leading coefficient there. Okay, well, that negative 2 is going to come from x plus 2 as a factor, but they're telling me that it appears as a factor 3 different times. So I'm going to give it an outside exponent of 3. That's the x plus 2 cubed, which is a 0 of negative 2 and a multiplicity of 3. We also end up with a 5, so that would come from x minus 5. It's to the first part. You don't really need to write the 1, but recognizing that I could write the 1. If we were to expand this out, we'd have an x plus 2 times an x plus 2 times an x plus 2 times an x minus 5. So if I multiply all that out, I have an x to the third times an x, giving me my 4th degree polynomial like they said we would have.